This video is about aeronautical charts. We'll talk about basic concepts, navigation skills, sectionals, and of course this is your Charlotte sectional that you should be getting a copy of. There's the main page of your Charlotte sectional, and this is the legend. We'll talk about both of those in today's video. The first thing they talk about in your textbook, which is your private pilot textbook, is your Jepson. This is it, and you need to get a copy of it as quick as you can. They talk about a reference system for finding your position on the Earth, and of course that's latitude and longitude. They first define a great circle, which is any line or plane that cuts through the center of the Earth. Latitude only has one. The equator is a great circle, and you can see that all of these other lines don't cut through the center of the Earth. Every line of longitude is a plane that cuts the Earth through the center or through its axis of rotation. So every line of longitude is in fact a great circle or meridian. Latitude, again, the reference line is at the equator, and that's 0 degrees. And you go north and south 90 degrees. It's basically a right angle from the center of the Earth. That's why it's 90 degrees. All latitude lines are parallel, and they're equidistant. This means their distance between them are equal. 60 minutes is equal to 1 degree, and 1 minute of latitude is 1 nautical mile. So when you try to measure distance on your sectional chart, you can actually use the latitude lines, the vertical lines, 1 degree, and count that as 1 nautical mile. We'll talk about what a nautical mile is a little bit later. Longitude lines are all great circles. They're called meridians. The reference line goes through the Greenwich Observatory in England. You can see it right here. And you go east or you go west 180 degrees, which is basically halfway around the world. It's measured east and west from the prime meridian. North Carolina is about 76 degrees to the west, so that's why we're about 5 hours behind England, or the prime meridian. We're also about 36 degrees north, so right here is about 36 degrees north and about 76 degrees west. 15 degrees is equal to 1 hour, and that makes sense because it's 24 hours and 360 degrees. If you do the math and reduce it, then 15 will be 1 hour. 15 degrees is 1 hour. So longitude and latitude measurements are divided into degrees. The degrees are divided into 60 minutes and are divided into 60 seconds. Map projections. We are looking at trying to get a sphere onto a flat piece of paper. And so this is called a Mercator projection. And you can see that as you go into the north and the south, as you get away from the equator, the actual distances get really distorted because you're trying to match, if you will, the grid lines on a sphere on a flat piece of paper. This is typical of a chart that you would see on a wall, or a wall chart. So the Mercator projection is used for most wall maps, and you can take a globe and project it onto that flat surface. And the scales become, again, very distorted at high north and south latitudes. The Lambert conic projection right here is you're basically taking a cone and putting it on the sphere. So if you look at it from above, it looks like this. Our aviation charts and sectionals, basically because they only take one little spot or on the Earth, especially like the Charlotte sectional, only covers North and South Carolina, they are in fact Lambert conic projections, which it really increases the accuracy. Go ahead and pause the video now, if you would, and practice with your latitude and longitudes, and find the latitude and longitude of these following cities here: Hobart, Australia; Washington; Moscow, Russia; Los Angeles; Tokyo, and Japan. Go ahead and pause and write down someplace what those latitudes and longitudes are. Now, using your Charlotte sectional, I want you to find the latitude and longitude of these following airports, okay? Find the latitude and longitude of these following airports, okay? I want you to do it on your Charlotte sectional using the latitude and the longitude lines. You can see them right here. And then once you finish that, you can check your work by using Google Maps and finding the latitude and longitude. I want you to do Moore County Airport, Piedmont Triad in Greensboro, Seymour Johnson in Goldsboro, Stanley County, which is just west of here, and then Raleigh Exec, which is in Sanford. Find the latitude and longitude. You can pause the video and go ahead and write down these latitude and longitudes from your chart. Go ahead and plot those. Talking about VFR sectionals and terminal charts, you can see here there are 48 sectionals based on what the major city airport. We again, of course, are Charlotte right here, the Charlotte sectional. The purple squares here are terminal area charts, which are basically, if you have a very busy airport, they'll have a separate chart of their own with a larger scale to give you more details. Again, the VFR sectional charts, the FAA publishes the sectional charts of all the U.S. states, Alaska, Hawaii, Puerto Rico, and the Virgin Islands. They cover about 4 degrees north and south latitude and 6 to 8 degrees east and west longitude. So they're not that big. The scale of the charts are 1 to 500,000, or 1 inch on the chart is equal to 500,000 inches on the ground. And so 1 inch on the chart is about 7 nautical miles or 8 statute miles, where 1 nautical mile is 2,000 yards or 1 minute of latitude. There you go, 2,000 yards. And 1 statute mile is about 5,280 feet or 1,760 yards. Sectionals are labeled for the major city that falls on, and you'll be using the Charlotte sectional. And for flight, you can download a PDF copy to use on a iPad or computer, or you can use your paper copy here, which is fine. And this is, of course, this is the Indianapolis sectional that is the example on here. They're updated every 6 months. The one I'm have here is last fall's, and it went bad the 2nd of January, so I wouldn't want to use that for aviation. Okay, again, the terminal chart has a very larger scale, which is 1 to 250, which is basically twice as larger scale as the sectional, and it covers the airspace around a major airport such as this, or Charlotte. On the regular sectionals, you'll see a white square which depicts your terminal area chart, so you'll see that. Okay, let's, if you would, go ahead and pause the video after you read this. What I want you to do is we're going to find these 3 airports, use your plotter to figure out the true heading between Moore County Airport and Asheboro Airport and Charlotte Airport, and then Charlotte Airport and Moore County Airport. And you'll have to use your navigation plotter for that. There's some videos on your notes for this section that actually show you how to use the plotter. So if you have questions about that, take a look at those videos. Okay, the legends and symbology on your map, on this part of the map, okay, we'll throw that up there so you can see it. This part of the map is your legend, and again it's divided into 8 blocks, and the 8 blocks are airports and data right here. There's airports and airports data, radio and nav aids right here, communication boxes right here, ATC services right here, and your obstructions, which look like this, your topographic features over here, and other miscellaneous information in this block right here. And they're all located on your backside, legend side. On the obstructions, they're all man-made obstructions. The symbols represent the height. The taller towers look like this, and the lower towers look like this. The sectional shows if there are multiple obstructions, and then the obstructions can be radio towers, power lines, tall buildings, anything that will obstruct aviation. You'll notice here that the heights are listed in AGL, which is, this is how far it is above the ground, and MSL. This is what you'd be reading on your altimeter. So it's very, very important that you have both of these altitudes. Your airport symbols and your airport data. Again, it will tell you whether you have 1 or 2 runways. It'll tell you whether the runway is hard surface. It'll tell you the runway length and the nav aid location at the airport. tell you whether there's a rotating beacon or light, and of course the type of use of the airport: private, military, civilian, land or sea base. And again, the airport symbols will tell you if it's blue, it's going to be a controlled airport. If it's magenta, it's going to be uncontrolled. Then on your map here, you'll see every airport will have these designations around it, and they will tell you basically the name of the airport, whether it has a control tower or not, and the frequency, whether it has a light or not. It'll tell you ATIS, which gives you information on the airport, tell you the elevation, the length of the runway, and light of runway there, right here, 7,200 feet. Has a Unicom frequency, and whether the pattern is standard left hand or in this case right hand pattern for each of the runways. So it gives you all kinds of information, and the key to that is right here. Okay, again, the airport data right here is flight service. Airport is if it's at the airport, airport name, the control tower, and so forth right here. Okay, just like I went over just a minute ago, and it's all contained right here, and that's listed on your sectional. Navigation aids, and communication boxes. These will tell you the navigation aids. This will tell you flight service right here. It can be a VOR. Here it is right there. It can be a VORTAC, okay, which is a combination of VOR and a TACAN. It can be VOR DME. It can be an NDB, or it can be an NDB and DME. And again, 121, if there's an R, it indicates that the flight service will receive your radio transmission, but will only be able to transmit back via a repeater that's in the local nav aid. Okay, so right there, 121R. You would want to tune up to the Oakdale nav aid here on 362 on an NDB to listen to a transmission back to the airplane. Okay, AT Airport Traffic Service and Airspace Information is in this box. You can see it'll tell you whether you're in Class B, Class C, the types of airspace that you're in, and the boundaries of that airspace. So it'll tell you your Victor Airways, your RNAV waypoints, warning and restricted areas, prohibited areas, areas with TIRSA, which, by the way, Wilmington Airport ILM has TIRSA, military training routes, operating areas, alert areas, aided zones, which is basically coming in and out of the United States, national security, no-fly zone like Washington, D.C., low-altitude helicopter-only routes, and control tower approaches and frequencies. It'll give you special conservation boundaries where, like at Cape Hatteras, vertical separation of 2,000 feet will be required. And that's basically a blue line with dots in it. Okay. Topo features, again, they're going to have roads, railroads, power lines, cables, outdoor theaters, all kinds of things that you can see from the air. And the colors on the map will indicate the elevation. You'll see rivers, lakes, and other water features, of course, will be in blue. Miscellaneous would be any other activity that can affect aviation. It will tell you the compass variation. Deviation will actually be in the airplane. Areas of aerial activity and VFR waypoints, GPS waypoints. What I'd like you to do now is check up on your chart, go to page 456, 57 in your text, and do those problems, and they are due. Go to your chart user's guide, which you downloaded as a PDF. The next slide will be 12 symbols. Go to the CUG and identify those symbols. Now, everything that's in this PowerPoint will in fact be on the quiz when we bring it up next week. Okay, so be ready. Go through this, be able to plot, be able to identify the legend, and be familiar with the symbols so that you'll be ready for the quiz. Okay. Here's your symbols. And that concludes our video.